Hey, this is a quick video on how I helped one of the users set up a MIS rig to drive an existing skeleton. So this enjoyably named skeleton was from the Unity store, and they needed to get a another MIS skeleton to drive it. But the problem was one of the concerns was the orientation here is not the orientation of MIS, and so they wanted to see if we could use MIS to do it, and it worked fine. There's a couple of caveats, so I'll go over those real quick, but I just kind of wanted to show how you would do that. So what I did was just made a MIS template and just snapped to the existing points, and then we built our skeleton. So then what we have is the MIS rig that is oriented differently. Let me turn on skeleton on. So that's not mine, that one's mine. Okay, so you see this is the traditional MIS orientation of ZYX, Z aim, Y up, X out, but it will drive the other bit, they're fine. The caveat I was going to say is that for this skeleton had limits on the rotations, and so initially we were having issues where it was just not behaving properly, and that's why. So I did a quick call just to turn those off. I'll show you that in a second. But the other part is like, okay, so once you have that, how do you drive the other skeleton with your MIS setup? And so to do that, what I did was just make a mapping dictionary, and then made a call to actually drive those constraints how we needed to have them. I tried a couple different options. I think we ended up with the point orient, but I just wanted to show how you would do kind of that mapping setup. So to do that, I used some meta code here. So first thing I'm going to do is I'm going to select this skeleton, and that's going to be my target. And then to get my driver skeleton, I'm just going to use builder to from the spine below, skeleton, get bind. So that's one way. The other way is to if I just go up to the actual master and then skeleton, if I select this and I go to CGM, select children joints, it'll just grab joints and nothing else, which is what I want. And so I'm going to make that my driver setup. So what that is just a meta list of those joints. So that I can do stuff with them. And our meta stuff works off of Red 9's meta class as a basis. It's an object-oriented setup, similar to PyML. It's just a little different take on it. I don't use PyML. I just use Mark's stuff as the basis and build our own stuff on top. I'm going to grab distance stuff to be able to match. And then, so what I want to do is I'm going to make a new dictionary. And so I'm going to say for every object in my target, I'm going to get the closest target of my source list. And then I'm just going to print it for now. Actually, I'll just go ahead and do the mapping. And then I'm going to map it to that dictionary with the key being the closest object, and then its target being the string, the short string. So what that looks like is, there's all the mappings, and then if I do a pp print on this, you'll see the mapping of the skeleton of the dictionary. So it's the dictionary to its driver. So there's the driver over there. So, and then I just use that dictionary as a data point with the whatever mapper I have to actually do the constraints. And it's just a matter of going through each of the drivers to the target and doing whatever setup you want. I think I ended up doing I created an exact match object and then parented it in the rig skeleton, and that worked well. So just want to do a quick demo of this. This is a basic workflow of how you do it. You can drive other orientations of skeleton from MIS. I also think actually I didn't end up using the bind skeleton. I walked up to find the rig skeleton from this, and that's, you can just do that via the message mapping on the on the joint. So there's the rig joint. I use the rig joint to target it, just so I wasn't having an extra complete set of constraints that were having to be done. I could get rid of these constraints and just run off the rig skeleton. So anyway, hope this is helpful. Hope you have a good day. Talk soon.